Okay, go ahead and start the recording here. I'm Logan Strauss. I'm the TA for Don's sections here of 498 as well as the 422 machine learning class. Graduated from the Northwestern program back in actually June of 2021, and I've stayed involved with it through the course of the TAing here and helping out and trying to stay engaged with the class and continue to meet students and help them on their journeys. In my day-to-day life, I'm a data scientist for university hospitals here in Cleveland. And it's been a very rewarding career decision for myself, making the change from logistics and transportation into healthcare. And just to give a quick background, I couldn't have done that without going through the program and everything that, this whole entire group's went through over these last few years. So for those of you that are, in 498 here and getting towards the end, congratulations. All your hard work here will pay off, whatever your career goals are, whether it be to stay with the same company you're with today or, do a pivot like myself and jump into something completely new. So with that being said, I look forward to meeting each and every one of you that I've not talked to yet and hear what you guys have to present here. For those that have had an opportunity to go ahead and sign up, I appreciate that. Go ahead and give a little bit of priority to those folks that did take the time to sign up for today's presentation. If you didn't get a chance to sign up, that's okay. We'll still give you an opportunity to present here and give feedback. With that being said, if there is somebody here that has a time constraint that they have to be off here within a certain amount of time for a family reason or something else or personal reasons, let me know and I'll do what I can to move you forward this evening. So with that being said, I'm going to go ahead. I got the sheet here in front of me. Lewis, would you mind going first here?
Absolutely. So I'm going to quickly introduce myself. My name is Lewis Lane. I am in my final quarter with the program. I decided to do the AI specialization, and today I will be presenting a startup that I'm actually doing and trying to develop. By no means is this a sell, but I would love any feedback or input that you guys may have on what I am going to show. So with that, let me still the screen. A lot of junk there. Okay. If everyone can see my screen, what I'm presenting is a startup called MyView, which is a data assistant tool that enables anyone within an organization to get insight using natural language. The entire idea is that you essentially, our data exists somewhere and we have data questions, but as most of us know, there's a lot of headache with getting insights quickly if we're being bunkered down by a bunch of requests, or even if the end user stakeholder doesn't quite know what they want, this tool essentially enables them to query their data as they like. I'm going to try something crazy here in the next couple of minutes. First, just do a quick overview of what the tool is, and then actually try to show the benefit of it by creating a dashboard using it. So this is just the landing page. Here's just a quick little demo just to see how everything works. Here's the iris data set. Using this input box, I'm just saying, tell me about my data, which generates a summary table for me so I can actually see some of the columns of interest and everything else within this data set. I can take it a step further and say something like, show me a pie chart. Average by species. And you will click on me. So that should have worked. I'm not really sure why I did it. You know what? We're just going to skip straight actually into the meat of the demo. Go to upload. Okay, so what I'm going to do is essentially use this data science galleries data set that I got from Kaggle. I figured it'd be kind of important or significant to us, and I'm going to try to upload the data, ask some basic questions, and then build out a dashboard over the next couple of minutes. So this one and upload it. This just shows me a quick preview of the actual data that I'm uploading into the system. From there, we're able to go to insights. This is where we'll ask most of our questions. So tell me about my data. Do that there. I did go ahead and prep some questions beforehand, just so we can go kind of fly through this because of the time constraint. But essentially, we can import or place our questions here, give our questions some type of title. So let's just do because I was looking for a bar chart, sorry. So yeah, here we're able to just see that we're able to generate a bar chart for the average salary. We can do the exact same thing for a variety of different questions. I'm just gonna throw some things here, that way it will break. I'm not sure why it broke. It should have worked, but essentially what we should have been able to do, show me a bar chart, experience level. Not sure why it's breaking now, which is super embarrassing, but essentially we should be able to ask basic questions using just natural language to generate the visuals that's needed. As you guys can see, I'm still working through some things for sure. I started this about a month ago. So it's a lot of coding, a lot of natural language involved. Everything is ran using Go, and then of course, HTML, JavaScript, and CSS. I'm not sure why it's breaking right now, but I'm going to stop sharing so I can work out some of those bugs. Anyone will be interested in, I know that was a horrible demo, but if anyone will be interested in actually seeing more of this, I promise you it works. I'm not sure why it's breaking. I think it's like the demo curse. I'm going to drop an email in the chat, and I did go ahead and create a Slack essentially for this, where I'm going to be posting demos and updates on the tool. And then I'm hoping to work out these bugs by the end of this month.
No, that's really cool there, Lewis. Thanks for sharing that there. It's very professional looking. So just out of curiosity, the framework, and if I missed it, what framework did you use for that? Or did you do that all from scratch? Because it looks a little bit like Angular, but I'm not sure if it's Angular or not.
Yeah, so it's all from scratch.
Wow.
So
Okay.
yeah, a lot of headache and a lot of back and forth, just trying to figure out where everything is connected. But the language stack is just Go, HTML, CSS, and JavaScript in the purest of sense.
Yep.
There's some libraries I'm using in Go just to do some of the language parsing. But outside of that, a lot of it is just from scratch.
No, thanks for sharing that there. If anybody has any questions here for Lewis, feel free to go ahead and ping him here. He sent his email there in the chat. And if anybody wants to ask a question, you can ask a question now. But one very important point that he brought up there that I'd like to just draw some attention to is that he brought up the point of using Go. Go is one of the newer languages within the last couple of years. It's gaining a lot of popularity. It's a product out of Google's ecosystem, something that they developed and then they open sourced, and it's gaining some traction significantly here really within the last 6 to 9 months. I've noticed in different applications in terms of being used for data science purposes and building applications, and it's the processing speed of it is something that has over top of Python. Python isn't exactly the fastest language out there. That's why you hear a lot of comments about it in comparison to C and stuff like that. So Go tries to solve some of that gap with its performance. And Lewis, if I'm completely off base here, let me know. That's just some of the stuff I've read about it. If there's anything else you want to share.
Essentially, so I did try to develop this once with Python, but handling the data manipulations, it bogged down really, it bogged down a lot. Go is able to zip through it quite quickly. There's one data set that it still has some challenges with, but outside of that, I mean, it's able to chew through, loading and manipulations quite quickly.
Very cool. Okay, Lewis, if there's anything else you want to show later on, just go ahead and ping us and feel free to hop in whenever. Sarah, did you have something you wanted to ask there by chance?
Yeah, I was going to ask if you use any NL to SQL or NLIDB models in your backend.
So right now, because I'm not actually going to like a data storage solution, is just analyzing or pretty much storing everything in JSON files and then pulling that back down and then performing the manipulations on there. essentially the demo that was being shown there is stores the CSV locally, and then I'm able to kind of extract the information I need and store that in a JSON, and then pull it back for later retrieval when I need it.
I have a question.
Yep, good. Go ahead, Aruna.
Yeah. So, so for the translation of the query to what has to be done, is it rule-based or model-based?
So it's it's half role-based, and then the other half is just NLU. So it's pretty much natural language understanding. So just figuring out which part of the text should be analyzed, and then depending on that, I'm handing that off to a series of functions to make sure that is being translated and actually the right data manipulations are being performed accurately.
Are you using any specific libraries and pre-trained models for it, or have you trained anything for it for the model-based?
So for the model-based, Go actually has, and I can't remember the name of the link of the package off the top of my head. I will for sure message that to you if that's okay later. But there is a natural.
Thank you. Yeah.
There is a package out there that allows, and I believe that they even boast that it's just as good as something you'll find with like NLTK or other language packages. But there is a language package out there that does a good chunk of the work. So I'm just kind of building on top of that.
No, absolutely. I know BERT has a model for translating natural language into a query. It's still in the very early stages, but yeah, you can query from a single table. So I was curious to know if you will use something like that.
That's related to the NL to SQL stuff I was asking about.
Yeah. BERT. Yeah, I don't know if you got a chance to look at it, Sarah. I'll send it to you. Otherwise, it's pretty cool. I tried to do it, but I failed miserably. I could search from a single table, but the results weren't good at all. Like only select star from worked. So
yeah, NLIDB is going to be more broad than NL to SQL models. But yeah, my criticism of NL to SQL models in general is that they don't really support very good aggregations. So you can really only do very, very basic SQL queries.
Absolutely. And also multi-table like joins and stuff is,
it just doesn't work.
Kind of yeah, it doesn't work exactly. Yeah.
I would really love if you guys joined the Slack, because I think I have something to get around some of those challenges and limitations, especially the aggregate, right? Because at the business level, things aren't as simple as just the average of this variable. Is usually more complex than that. So there is a plan right now to build out an entire interface that allows for more dynamic aggregation that the end user can actually update. So, if you do have a data professional using a tool like this, they can in theory set that more advanced aggregate that's common amongst the practice or amongst the business, and allow the other end users to kind of use that in future queries.
No, absolutely. Thank you. Yeah.
Okay, thank you again, Louis. Go ahead and try to continue on here. The next person we have up is Sean. Sean, you ready to go here, sir?
Thanks, Logan. Hi, everyone. Just a quick introduction about myself. So I'm Sean. So live in Minnesota, and right now I'm in my last class for my programs for 98, and I'm working for an industrial company here on the business side, and specialize in AI in my through my Northwestern program. And today I'm going to kind of just a quick went through the demo for the computer vision project I've done for 462, which is based on AWS. I think a lot of probably you already have a lot of experience with AWS stuff. So the purpose just kind of share my experience about the ecosystem, and let me share my screen. That's it.
Yep, we can see it here. It looks really cool there, Sean.
Great. So the project is based on the AWS Deep Plans, which is the AI-based camera, basically, that's launched by Amazon years ago. And the project app down is basically develop a computer vision application with capability detecting and recognizing faces. I'm not going to go through all of these details, but basically it's a kind of a template oriented project that actually detecting the faces and then recognize the person in the camera and then generate the welcome message. All based on the AWS ecosystem. Here are the service that this project covers at3, Lambda, so on and so forth. So moving to the architecture, these are the service, as I mentioned earlier, that was covered in this project. It seems a little bit conflict, but there's two basically route. One is in this blue lines. So basically the camera captures the faces and then triggers Lambda function of AWS. And then the Lambda function will upload the image to the S3 buckets on AWS. And then it triggers another AWS Lambda function to send this message to the backend DynamoDB and AWS recognition AI service or auto ML services will kind of do the matching or indexing processing backend, and then return the result to see whether this is a face that has been registered in the backend or not, and tells who is that. So based on the name of the based of the faces that were recognized, it will generate the associated welcome message based by Amazon fully, and then yield like MP3 file to upload it back to the AWS S3 buckets. Another route is the face registration, which we did like app in front. So we uploaded the faces pictures into the another S3 buckets and use that Lambda again, to upload it to the recognition and then register with the DynamoDB. So the face detection process is actually leveraging the transfer learning, which is a pre-trained model called SSD, which is available in the AWS marketplace. It has a kind of a quite complicated architecture based on convolutional network. I'm not going through all the technical detail here. And this is a kind of an output logs that we came through. So basically, these are something that we use to test whether each steps or works out or not based on the logs from the AWS CloudWatch. So I can show maybe a quick demo about the result. Let's see. It's probably here. Let me know whether you can hear the voice or not. Here is a quick real demo.
Hello, Wayna. Do you love Anya? To play with Anya.
Some future work to. So this is a quick demo for that. So I guess experience, my experience with AWS. I just want to share with you all that some learning about dealing with AWS is that it's quite a robust platform, no doubt. But I've seen that there's less technical support for, I guess, free account that, especially that when you have some, coding issues, and there's a lot less, their technical supporting programs not that proactive as maybe Stack Overflow, some else. So you probably need to work with their technicians to kind of going through those problems. Another one is that I guess the runtime or the systems switching from Python 2.7 to Python 3.7. So there's some syntax changes that actually impact a little bit about your coding. But overall, the process is pretty smooth, and I learned a lot. This is a pretty template fundamental project. I'm sure you've seen a lot, so I just want to share with you all. So thanks.
No, thank you for sharing that there, Sean. Very interesting. AWS is a market leading tool right now that's out there. Very good skill sets. You can pick up, how to use some of these different aspects of it. It's definitely something I think it's marketable out there as well. So anybody have any questions here for Sean?
Yeah, I have a question. So
Sure.
Sean, how many images did you need to kind of train the model?
How many, what, sorry?
How many images did you need to feed?
Yeah, so the image is actually, I think I uploaded 3 persons. Each I load like 12 to 15 images, and I put them into like in different angles, different environment. I put into Amazon recognition. Those actually the model for training process, the model has been pre-trained with thousands, millions of images. Yeah.
No, I used OpenCV for my and deployed a similar not a similar one, but a face recognition application on a Raspberry Pi, and I also needed only like 3-4 images per person.
Yeah, I realized. Yeah, actually the TensorFlow Lite or the Google ecosystem is sometimes more convenient. I mean, there's a lot of developer and posts there to help you out, rather than sometimes AWS that there's always...
Deeplearn just has very little support. So yeah,
I agree.
Yeah.
Okay, any other questions there for Sean? Okay, no, thank you again, Sean. I appreciate that. If you want to go ahead and shoot that over some of those materials to myself and Dawn, we can go ahead and give you a few extra bonus points for the PowerPoint as well. So thank you for putting that together. And anybody that has additional, materials we presented tonight, feel free to send those over as well for Dawn to review. Okay, our next person up is Ed. Ed, are you ready to go here?
Yeah. This will be real quick. I don't necessarily have I don't have a PowerPoint or anything, but kind of just talking about the use of machine learning and deep learning in satellite imagery for classification. So for one of my other classes, I'm doing basically object detection using a convolutional neural network. It's pretty cool. I think that there's a lot of value that can come out of like satellite imagery. I think the traditional sense and the mainstream view of this is typically that it's used in defense, but it's used, as you can read right there, defense, mapping, agriculture, monitoring damage for natural disasters, real estate development as well. So some of the cool things, kind of just to show this. So basically, just presenting the scaling satellite imagery analysis. So the system that I'm actually building is actually through Google Cloud and whatnot. So basically, when you look through kind of like all this, it's the exact same thing, Logan, that we're learning in here. looking at basically, you know, like features. We're looking at predictive modeling. We're, you know, doing testing and training. And so this is effectively it's called Planet, basically a satellite imagery company. But yeah, you can basically use this and start kind of just tagging, you know, images and objects within this. I think this does a little. Oh, sorry, this is a little bit better. Here we go. So this is effectively what these convolutional neural networks can be used for in object detection, as you see. So this is that's a plane right here and a bunch of little planes. Let me go to the right here, and you see a bunch of other little planes as well. This is a pretty kind of standard model that you've seen. Some of the more advanced models are just going to have basically more features involved. You know, you could have something where it'll detect the building, it's going to detect the vehicles, or it'll even detect entire land masses. Some use cases that I've seen are basically in segmentation, mapping if it's an industrial satellite image of an industrial area, if it's an agricultural area, if it's effectively a densely populated city as well. So again, I think it's pretty cool to be able to build out these predictive models, and in a sense kind of use some computer vision to identify these things. So I wish I prepared a little bit better, and I apologize, but that's kind of what I have.
No, not a problem at all. They're very interesting to see that. Anybody have any questions here for Ed? Okay, doke. Thank you again there, Ed, for sharing that. We'll go ahead and move on here, and let me see who's next here on my list. Eliana, are you ready to go by chance?
Yes, I am.
Okay.
Hi, everyone. Thank you. My name is Eliana Goretti. This is my last class, 498 of the program. I am focusing on the analytics and modeling specialization. And I'm a firm believer in always learning more. The reason why I signed up for this program, but also I am trying to transition from a program manager role to data science type of career. And I thought I'll share with the class some resources that are available for us to just improve our certifications and learn more about, speaking of the Google Suite and the tools that are out there. I am looking to go towards a ML type of role in the future, and Northwestern definitely opened the path, but I work for a cloud company in tech, and Google is a platform that we do use. Having a certification definitely gets you that bump in salary, promotions, and so on, as we all know. But I recently discovered that they have these learning paths that you can choose to specialize deeper and familiarize yourself with some of the tools that are out there that can not just open more possibilities and ideas with your regular job right now, but also something that can help you maybe go into a different company. I was looking at this machine learning and AI. They do have free labs that you can actually practice with some of the tools, and you can get these skill badges added to your profile as you kind of complete some of the courses that they have. So they start with just the fundamentals, and then they go into BigQuery, Cloud Speech, AI platform, and it's really intuitive to use. AWS has their own suite of tools too, but I do find the Google ones a little more intuitive and easier to play with. So if, for example, I look at my profile, I did add the machine learning path, and it kind of shows you some of the badges that I've completed. But if I look at that particular course, you can just take your own pace at it. And I've been having fun kind of learning more about it. I'm trying to find the actual, okay, if I do learn more, you can select what course to enroll in, and it kind of takes you through getting to that certification stage. That's, I think it's about $200 to take, but that can directly translate into something tangible at work. And it could open doors to practice more once you have it. So I thought it was interesting to present to the class. That's what I have.
No, thank you for sharing that, Eliana. So your thoughts on that? Is there a reason why you chose the Google stuff over some of the other stuff that's out there, like the Coursera's of the world, or the, what else is there? Data camps and things like that. Is there any benefit with the Google stuff over some of those other outlets, or did you kind of just go with the Google thing because of work and all that?
No, I find it better than Coursera and the other more traditional places where you can get some certifications and new skills, because it connects you directly to the Google Cloud platform, and it has all of the tools that you can add any public data set, and you can kind of get your feet wet. And you don't have that time limit with Coursera. Usually you kind of have either 1 month to complete everything, and then you kind of lose your money. This one, you can just take your time with it and have your own pace. And I find it very valuable so far.
Oh, thank you for sharing that with the group here. So it sounds like to me, if you're looking to kind of fill some gaps, or, continue to, check that box, if it's, something for your company that they compensate you, either pay for it, or they go ahead and they give you a bump for having it, seems like a great thing to have an additional to maybe some of the things you learned in your data science program. Whether you went ahead and did the data engineering path and you want to do something a little bit, less technical, you can go ahead and take, a class like that, or vice versa. So thank you for sharing.
Definitely. Yeah.
No, thank you. Thank you again. Does anybody have any questions here for Eliana?
I have a follow-up question, kind of a on the Logan's question, that do you see like because you're insider, have you seen like the companies are recognizing the people who have this, or it's a more like a plus, or it's a kind of a necessary piece for your kind of a profile, or to maybe looking for a job in the.
Yeah, very insightful, Sean. I was just going to add that I noticed at my company, at least, the people that do have the latest Google or AWS certification, there's a direct bump in their pay. And, you kind of get credit every time you do that. So it's something that's, it helps to build more trust in yourself, but also with the people that you work with. And I've noticed they talk a lot about it. Like every team meeting that we have, someone that got a certification, they get a gift card, they get the next promotion. So I'm gonna capitalize on that too, and try to kind of get into a new career, because sometimes it is relationships and people that you know at work, but sometimes the hard skills talk for themselves. So yeah, going to a master's program, great. But what can you actually do with it, and what do you specialize in is kind of like the next step.
No, that's pretty cool. Especially if a company is willing to go ahead and give you a bump for directly getting that. Speak from personal experience, not every company does that. A lot of companies have the line that, they don't pay for degrees, they don't pay for certifications. So if you're at one that does, that's really cool. So take advantage of that.
You can also add them to your LinkedIn profile, and you might get more recruiters reaching out to you. And sometimes that could be another window that can open too.
For sure. Very cool. Okay. Thank you again, Eliana. And next person we have here to go is is Kim Law. So Kim, if you want to go ahead and take the stage here, I can go ahead
Awesome,
and
thank
take
you.
over.
So, can you hear me okay? Okay, I think my microphone is working. Hi, my name is Kim. I'm currently a technical program manager, and I am in my last class of the program. My major is for the Master's in Predictive Analytics, so I don't really have a concentration particularly, but I'm excited to wrap it up with such a great group of folks. My presentation is about applying data science in my day-to-day skills. So I am currently a technical program manager, and we recently had to go through some, I want to say, reevaluation of our work. And we had to really look hard to see like what we can improve on. And we're trying to figure out ways to scale our work without scaling the headcount because of budget constraints and et cetera, et cetera. So I'm just going to jump into the whole process of how everything happened. So I work in a team of also program managers and technical program managers. So it's very interesting to work in a team of just that kind of folk without any engineers. But the thing that we started out with was identifying our problem. And our main problem and question that we had here was, how do we land more impact in our organization and within our jobs without needing more people? And so the next step we did was deciding on our approach. So we did some evaluations. We looked at our current workload. We started to assign values to the different types of projects and different types of work that we were doing, and we were labeling them either impactful or non-impactful. And then we started labeling them into like things that we didn't really like to do, things that we did like to do. And then we needed hard data to actually do some analysis to see like which ones were the low-hanging fruit that would have given us those quick wins. So we started to collect data within our team and within our stakeholders, and that consists of multiple different mediums, including group discussions. We did surveys. I did multiple one-on-one sessions with people on my team and with leadership. And then we really spent a lot of time to identify toil. And toil, I don't know if everyone on the call is aware of the term, but it's essentially work that's not fun and doesn't really add much value in your mindset. It's a term used within DevOps. It's starting to, to be used more within IT. It really hits hard within my team, particularly because I work in security, and all of my teammates also work in security. So being in a space where there's lots of parallel and quick moving parts, and lots of processes that are just adding more and more burden to us to continue to push forward and move forward, was really important for us to see which ones weren't really necessary anymore. So after we collected the data, we did some analysis on it, and we identified what toil work meant to us and which of our tasks and our jobs were actually toil. And then we reviewed the results, we interpreted, and then we came up with a consensus on like what we needed to do, and it created the end result of it was that it allowed us to do proper roadmap planning for our team's future and like areas that we wanted to work on once we identify the toil. One of the lowest hanging fruits that we decided to jump in on, and this was very interesting to see, was that we decided that one of the biggest toil things that we did was that we write reports depending on the type of assessments that we did. So now my team is working on, for one of our objectives for the quarter or for the semester, is that we're creating an automated report system where we quickly find, we type in the findings or we collect the data from our targets or the other project teams. And then we utilize that to connect to quick standardized results. And that also connects to policies that we currently have and action items that those project teams can act on in order to improve their security posture. So by going through this framework that we've learned within school, we were able to essentially come up very quickly with not only a roadmap for our team, but also identify areas that we could apply automation so that we could save each other lots of time. So this is just a slide that how we define toil. So when we were looking at our workload, we looked at different areas that we felt weren't adding as much value. And some of the characteristics was it manual? Was the work repetitive? Was it automatable? Was it tactical? Or was it strategy driven? And I could say a lot of the work that I do is tactical because things blow up left and right. And how do we approach that? Like, it really opened up a lot of questions for us to answer as well as a group. So these are really useful. Also, was it scalable? And we found out some of our processes and evaluation techniques and assessment techniques were not scalable at all. And it just added a lot more toil to our workloads as we had a lot more engagements with other teams. And just a note here is that grunt work is not toil. It might not be fun to get your hands dirty once in a while, but from my work experience, we do need to get our hands dirty in order to get the results that we need to at times, which is basically my whole talk. Let me just click. Yep, I'm done. Any questions, comments about toil?
No, it's very, very technical there, Kim. Thank you for sharing that. I mean, not all of us have a decade of experience here in your expertise. I know you're very talented at your cybersecurity roles at the multiple companies you've been at. So thank you for, sharing, a little bit of insight into that today. So anybody have any questions here about Kim, about her project?
I do wanted to add that, like, all of this is high level and taking that completely out of context from what I do, but it's also this methodology can be applied to like various aspects of our lives, and it can improve it kind of blows my mind if I think about it from a high level perspective. So outside of the awesome, cool things that we're seeing right now through all the other presentations, it's also just, if we take the concepts and apply in our lives in different ways, we could also see the benefit from that as well. So that has been another benefit being in the program so far.
Okay, doke. Thank you again. Somebody want to add something there or ask Kim a question? Okay, well, Kim, I was expecting you to show your little doggy there as well. Everybody likes Hamilton, but looks like he's not hanging around there today. Oh, you're on mute. That's okay.
Oh, he's out of commission, so
Oh.
I don't know where he's at.
Okie doke. Thank you again, Kim. We'll go ahead and move on here to our next person here, which is Sarah. Sarah, are you ready to go here?
Yes, let me just share my screen.
Thank you.
All right. Are you able to see my screen now?
Yes, we can see it.
Okay, perfect. Yeah, so hi everyone. My name is Sarah Rodenbeck. I'm a senior research data scientist at Purdue University. So I primarily work with natural language processing, but also just kind of general machine learning. So today I'm going to talk about distributed data annotation pipelines. So most of the assignments in this program that you've done throughout your master's, I'm assuming you've primarily just kind of received labeled data, and then the assignment has been to analyze it from there. But in my experience, really the process often starts a lot earlier than that, and that's with the data annotation. So machine learning and deep learning, they require obviously a lot of labeled data, tens of thousands of data points often. And so while we sometimes do get lucky and there's some sort of existing labeled data set we can use, in many cases, we're working on some sort of novel project where there really is no labeled data set. And so that's what I want to talk about today. So annotation can look like a lot of different things. It can be humans labeling something as a success or failure, labeling where the crosswalks are in a CAPTCHA, translating a document, etc. But really, I want to focus on the implications of distributed annotation. So the scale of data in deep learning basically means that it's not really well suited for one person to do all the annotations, but that opens you up to a lot more logistic issues. There are, of course, different services out there like Mechanical Turk, where you can crowdsource annotations. Personally, though, I've found that these are often not financially or temporally advantageous for the projects I've worked on. especially if the type of annotations you need require any sort of domain knowledge. And so I'm going to kind of focus today on how you might go about doing any kind of internal efforts. So some of the logistics that you kind of open yourself up to if you're trying to do distributed annotation would be, how you coordinate it, how you ensure consistency between the annotators, and then also how you distribute data and kind of just plan the project as a whole. So I'm going to talk today about the statistics and training and tools for this and how I've done in the past. So the best tool I've found for doing this is something called Docino. It's an open source annotation platform, and I've used it for several large projects now. And honestly, something I would highly, highly recommend. If you're going to be doing it for a large scale effort, though, one of the key points to remember is that you have to deploy the application in some way so that all of your annotators can access the same platform and annotate from there. So if you have access to a cluster, what I've done in the past is used Kubernetes to deploy it. And then I think also the GitHub for Docino does offer some sort of feature for one-click deployment through, I believe it's Heroku and AWS. But those are really good features out there that you can use. The second step is training, of course. So essentially, the idea is you need to make sure everyone's on the same page. A lot of these things might seem pretty obvious, but I think that they're pretty key, especially if you have ambiguous data. So the first thing that I really recommend is being able to do some annotations yourself first as you're writing your kind of written guide or documentation. And that just really helps you get better acquainted with the data. The second thing that I recommend is having a kickoff meeting to basically go through everything with the group, and then also doing some annotations together, which kind of helps get everyone on the same page. And then the final thing that I recommend is having all annotators do a pre-test where everyone kind of annotates the same small data set, maybe a couple hundred data points. And then from there, that allows you to do statistical analyses to identify any annotation outliers, as well as any things that people might have some confusion on and are rating things differently. And so then prior to the main phase of annotations, the group can all get back together and go over the pre-test results. Then the final thing I would mention with training is that it's also beneficial to have some sort of mechanism like Slack through which users can, just ask questions. And then the last thing I want to talk about is statistics. So I mentioned in the last slide having a pre-test where everyone annotates the same data. And that's really key for being able to establish inter-annotator accuracy or inter-rater reliability, to kind of similar terms. But there are a lot of different metrics that you can use for that depending on the type of annotations you have. Some of the most common ones I've used for classification tasks where you have multiple annotators are things like Fleiss's kappa and Krippendorf's alpha, but there are really all sorts of different metrics out there depending on what your data looks like. If you use these or really any other type of metrics, one of the things that I think is really interesting to do is to try to customize the distance functions that you're using with these metrics. And that can give you a much better idea of how off different annotators are, especially or assuming that there's some sort of ordinality or hierarchy to your labels. Some other metrics that might be useful are things like pairwise percent agreements or overlap if you have like span-based annotations. And then to avoid issues with data quality, I also think it's really useful to have multiple people annotate the same piece of data in your main phase. So I typically randomize the data distribution. So each piece of data is annotated by at least 2 people. And then depending on the sensitivity of your project, this allows you to then kind of filter as you're training and only train with those data points that have at least a 75% agreement upon or with annotators, for example. So my key takeaway with all this, basically, data annotation is not super exciting, but it is a really key part of the machine learning pipeline. And it does have huge implications on the performance of downstream models. So it is definitely worth the effort.
Very nice, Sarah. Thank you for sharing that. Does anybody have any questions here for Sarah? Okay, we'll go ahead and continue on here. I know we're getting up here close to 8 o'clock Central, 9 o'clock Eastern. So I'll go ahead and continue on here. Aruna, have I given you a chance to go yet?
Not yet.
Okay, yep, go ahead here.
Okay, let me share my screen. I have no slides. I just pulled up a couple of websites that I can go over. So
yeah.
Pardon me for not being prepared. Okay, so today I want to talk briefly about distributed computing, basically Spark and the PySpark library. So what it is and how it can be used, right? So when you want to define a big data, the big in the big data, I'd like to define it as something that you can fit in a single machine's storage. Leave the RAM alone, let the RAM be, but if you can fit it in a storage, then that's the big data. Say for instance, you have petabytes of data in real world. And then I had an encounter with 250 million rows of data. So big data. So how would you typically do your operations on them, right? So that's kind of like capturing the data, storing, analyzing the big data. That's a big challenge. And I think that's where distributed computing really helps. So you could run, so there are two ways that and there are many ways you can do it. Basically, you can, let me open this. So you can have, this is distributed computing, and then you also have parallel computing where you take a task and then the operations happen parallelly, right? So in distributed, you distribute the task to different machines, and then the processing happens that way. So basically, let me go here. Okay, so when you talk about Spark, and so around 2014-ish, that's when Spark was introduced. And yeah, I think it is 2014, but yeah, I might be wrong. So it got introduced in the market, improving upon the existing Hadoop's infrastructure, right? That was already in the market. And the advantage of Spark had was it was much faster, and it was suitable for iterative tasks. So basically the issues with Hadoop was every time it did an operation, it was writing into the disk. So it needed that much more resources. So with Spark, and we all know how much of the resources we need for in most ML trainings, right? So the Spark kind of served the purpose for that. So the idea is that you take a big task and then you break it down into smaller tasks, and then run it parallelly instead of sequentially. And then you have your results generated. So you have a driver program, and then you have a cluster manager, and then you have the worker nodes. So the worker nodes are the nodes that perform the tasks. The driver manager assigns the task to the worker nodes. So basically, if you have a large data set, it gets split and then it gets distributed to the worker nodes. The cluster manager here lets the driver program know that the amount of resources each of the cluster has, right? So that's kind of the cluster manager's job. And so that's pretty much how the processing takes place here. Now, when you talk about how you do all of this, right? So Python has a library called PySpark, and it's as simple as using you can just install it saying pip install PySpark. It's as simple as that. So now this library, it helps you use the agility of Python, right? And to interact with the system, like the Spark is written in Scala, so you can interact with Spark using this Python library called PySpark, and it's very powerful. So a little bit on, let me show you. Yeah, so there are a couple of data structures of this library. So there are RDDs and there are data frames. So RDDs are not tabular in nature, but the data frames they're called the Spark data frames. And I think under the hood, they have pretty good optimization also. They're very similar to the Pandas data frame. They're not the same, but very similar. And they also have a lot of functions similar to the Pandas data frame. So also, the RDDs are a little slower compared to the data frames itself. I don't have I've never worked with RDDs, but I have with the Spark data frame. So I don't know much about them. Then let me go over. Okay. So basically, there are in the PySpark library itself, we have we have four different parts, right? There's one which is called Spark SQL, and that's what is used. It has all the commands basically for all the data processing manipulation. For instance, you have, say, for instance, in my case, I had about 250 million records, and then we had to do, one of the operations we had to do was visualization and aggregation of data. So in that case, we used the commands and the functions from the Spark SQL. There's also MLlib, PySpark MLlib, which has a ton of machine learning models that you can use for, and then run those the training jobs in your say in your here worker nodes. So that's an option. Other than that, you also have streaming service and graphics. I don't know a lot about them, so I won't talk about them, but there are typically 4 different types there. So so when we did this, I used the Elastic MapReduce, which is a AWS service to accomplish the task. So so a good thing about EMR is that it supports both I know it supports Hadoop and Spark. So we use Spark. So when you have parallel processing and distributed computing like this, in AWS, what happens is it separates the compute from storage. So if you look at the Hadoop ecosystem, you have MapReduce and you have the Hadoop file system, but it's all like it's kind of interconnected. And if you have to scale one, there is some kind of dependency within one another. But here in EMR, the way AWS has split it is that you have, if you want to scale up just the storage because you have more number of records, or you have like many more petabytes of data that you're expecting, so that can be scaled up, the storage alone. And typically S3 is used to store data. And if you want to increase your compute power, then you can increase the number of clusters or number of worker nodes, you would say here in your Elastic MapReduce. So basically, you would have your data here, and then you would go to EMR, and then you would, and it's very simple in AWS. Like you don't have to do a lot of operations. You go here to the master node, we call it master node, and there you can go and can give you a .py file which has your code of what you want to do, and say for instance a simple aggregation, right? And then you import. That's where you would have imported your PySpark library, and you have your code there. You import your code. You import your code here, and you select how many clusters you want. Say for instance 2 or 5, and then resources for each cluster. All of those you just set it here, and in the EMR, like basically this EMR here would be this. Once you do that and you hit submit, your processing is completed and you get your results, and the processing is parallel. So it's as simple as that. And then your storage you can increase, or your compute you can increase by the number of clusters or the resources. So that is EMR, and that's all I had for today.
No, very good there, Aruna. That was very insightful there as well. So thank you for sharing this. And like I say, anybody that presents this versus a PowerPoint, it's all the same. It's just appreciate you sharing some type of literature here, or even speaking. There's nothing wrong if you just got up and spoke as well. So that being said, I believe the next person up here is Dana. Have you had a chance to go yet?
No, I haven't, but I'm ready to.
Okay, yep, go ahead, Dana. Thank you.
Awesome. Okay, let me share my screen. Okay, can everyone see my screen?
Yep, we can see it.
Yep, and you see you can see data visualization, right?
I see something here, information is beautiful.net. That's what we see.
Yes, okay, great. I have a couple screens, so just want to make sure. All right. So very brief introduction of myself. I'm a supply chain analyst, and I'm in my very last class of the program. Very excited to be done, but also very thankful and for the program and all the wonderful people I've met throughout it, especially my capstone group. They're just a bunch of amazing people. And so what I want to share with you guys today is a site called informationisbeautiful.net. So this is pretty much my favorite data science website. This is a website that focuses on data visualizations through graphs and other graphic styles to display data. As we've kind of learned throughout a lot of classes, displaying data in a easy to digest format is really crucial to explain your findings to stakeholders and upper management. And I think this website does a really great job of that. So I first was introduced to this website in 2021, so a little over a year ago. And this is what it looked like just a little over a year ago. This is what the site looks like now. So it has expanded to a variety of different areas, tons of different visualization tools and data for you to explore. And so this is just one of my favorite websites because you have a variety of different topics here. The one that I go to most often is beautiful news. So this has a variety of visualizations and it changes every single day. There's a brand new set of data visuals every time you visit the site. And as you scroll down, it just keeps giving you more and more and more on top of new things. And it's always something different. Here we have biodegradable alternatives to single-use plastics. Scroll down a little bit more, life expectancy in Africa. Keep scrolling. Here you've got 10 diseases we've nearly controlled or eradicated. If you just keep scrolling, it provides you with even more data visualizations. So this website was started by David McCandless. That's him right here. And he's expanded to a team now. But he's a writer, designer, and creative director living in London. So he started Information is Beautiful and has expanded on it. He's actually also putting together something called Viz Suite, which is actually, that's going to be a program that you can download, a high-end tool for creating beautiful interactive and data visualizations. So right now it's a startup and it's by invite only, but he does say on his website, you could always, shoot him a message and see if he'll, accept your invitation. So that is still coming. But I just really love this because you can find so many different visualizations to help you with your message. And then once Viz Suite becomes available, you can use your own data to create visualizations. So he actually has given a TED talk on this and the importance of data visualizations. He also holds a lot of talks, a lot of interactive speeches that he holds. So like right now for his 2020 calendar, I mean, it's mostly in the UK, but he does sometimes come out to the US, and he holds a lot of workshops online as well. So he really tries to spread the message of how important data visualization is. And he's actually also written 2 books. So the first one is called Visual Miscellaneum. And this one helps readers make sense of the countless statistics and random facts that constantly bombard us. He uses cutting edge graphs, charts, illustrations to creatively visualize the world's uprising relationships and compelling data, covering everything from the most pleasurable guilty pleasures to how long it takes different condiments to spoil to world maps of internet search terms. Then he came out with a second book not too long after that and that one is called Beautiful News. And that one focuses on fascinating positive developments at a time when the world has never seemed more dangerous and unpredictable. He draws from philosophy, spirituality, ecology, society, technology, history, science, economics, and pop culture to reveal positive trends and developments, from the invention of a breakthrough device that uses ocean forces to clean plastic from the world's seas, to a new method of converting donated blood to the crucial O negative type that can be used universally. So he's really passionate about this, and his passion has kind of inspired my passion about it. And what you can also do is, besides just going to Beautiful News that's updated all the time, you can actually go to any one of these, like for instance, Science and Health. And here we've got snake oil supplements, the coronavirus riskiest activities, stuff that just focuses on one topic instead of just little pieces of everything. The other thing that you can do is when you go to the data section here, you can actually see the actual data of where he generates all of these visualizations. So like if we were to click on ransomware attacks, if we were to go there, here we have not only a kind of short little, blurb about the updates, any related news to it, but when you see the data and you click on it, there it is. It's a Google Doc that has everything right there. It's raw. It's got a couple of different tabs here for you. So you can actually check out the random data, generate your own visualizations. And yeah, so this is informationisbeautiful.net. And this is, the one that he started with, Beautiful News, that's updated every day. And yeah, I just think that data visualizations are incredibly important whenever you're trying to explain your findings. And this really helps hit the point home. And that's all I have.
No, thank you for sharing that there. For sure, it has to be visually appealing and then intuitive. I think that's the biggest thing that, it gets lost in translation. Sometimes you think of data science or the general public that doesn't have a lot of information on what exactly the term means and how broad it is, and then how important it is to actually, provide your insights, because providing and translating your insights are, in my opinion, one of the most important skills you can have, because without that, it's very difficult to get buy-in on whatever you're trying to build for the company that you're currently with, or try to get them to, even give you the resources to build what you're trying to up front. So
Yeah,
thank you for sharing that. The quick question, was that stuff, is it just like, okay, for this type of business problem, you need to build a histogram or a pie chart? Is that the kind of suggestions that are in these books? Or is it more, provides code or whatever to actually reproduce these? Because I wasn't sure if that was, those are produced in R, or whether that was something a little bit more exotic, like, D3JS or something like that. Are you familiar with how he built some of those?
Not entirely, but I think the book does explain a little bit of it, and mostly just kind of delves into his passion for it and how to create like the maximum impact from what exactly you want to showcase.
Okay. Okay, no, thank you for sharing that. Try to see here. We had, does anybody have any questions here for Dana? Okay, I'll take that as a no. We had Agnes on there, I believe, as well, but it looks like within the last couple seconds, we just lost her. Other than that, has everybody else had a chance to present here? I'm going through the names here. It looks like we have. So, okay, about an hour and 15 minutes, hour and a half, not too bad here. I'll go ahead and stop the recording.